Welcome in Dark Core. NASA's Perseverance rover may have captured something remarkable above Mars, a thin streak of light that could be the interstellar comet 3IAtlas passing close to the planet. The image, taken on October 4, 2025, coincides exactly with the comet's predicted flyby. Although NASA has not yet confirmed its identity, the timing and geometry are compelling. If verified, this would mark the first time an interstellar comet was photographed from the surface of another world. In this video, we'll explore what Perseverance saw, how scientists are analyzing it, and why this event could redefine planetary observation. Let's get started. The journey to a light day. On October 4, Perseverance's right navigation camera, NavCam, recorded a faint, elongated streak across the Martian night sky. At first, it appeared like a meteor, but that's rare on Mars due to its thin atmosphere. What made the image stand out was its timing. It was captured within hours of 3IAtlas passing just 30 million kilometers from the red planet, its closest known approach. Because the geometry matched predictions, scientists quickly suspected a connection. Yet, with NASA's public communication limited by the US government shutdown, confirmation is pending, leaving the global scientific community to evaluate the evidence themselves. Astrophysicist Avi Loeb offered a technical interpretation that has since gained traction. He explained that the streak wasn't the comet's actual shape but a product of motion during long exposure. The NavCam captures multiple short exposures, each only about 3 seconds, and stacks them over several minutes to improve clarity in dim light. If a bright, fast-moving object passes during that time, its path appears as a continuous line. In this case, Loeb estimated the image represented roughly 10 minutes of movement across the Martian sky. That explanation fits both physics and timing. At its relative speed of about 67 km per second, 3IAtlas would have traversed several arc-minutes in that period, exactly what's visible in the composite. The streak's position also aligns with the comet's predicted track through Jezero crater's sky. Still, scientists remain cautious. A cosmic ray strike, processing artifact, or small near-Mars asteroid could, in principle, create similar streaks. But statistically, the coincidence with 3IAtlas's flyby makes that unlikely. If confirmed, this would be the first direct image of an interstellar object from another planet's surface, an achievement extending both the scope and symbolism of robotic exploration. What Voyager 1 is still teaching us? Even if faint, this observation offers powerful scientific value. Mars provides a second observation point far from Earth, more than 240 million kilometers away, creating a parallax baseline that allows astronomers to refine the comet's orbit and motion vector. When combined with data from Earth-based observatories, this helps model the object's trajectory, rotation, and tail dynamics with far greater precision. At the same time, ESA's Mars Express and ExoMars Trace Gas Orbiter, TGO, were monitoring 3IAtlas from orbit. Their instruments can analyze reflected light and gas emissions from the comet's coma, the glowing envelope of dust and vapor surrounding its nucleus. If the Perseverance image corresponds to their observation window, it provides a surface-level confirmation that complements orbital spectroscopy. Together, these data sets could reveal not just the comet's position, but also how its materials interacted with sunlight as it passed Mars. This type of multipoint observation represents a quiet revolution in planetary science. Rovers and orbiters, originally designed for local studies, are now doubling as distributed observatories. By coordinating across planets, they turn our solar system into a connected network for astronomical monitoring. Perseverance's image, whether definitive or not, demonstrates that capability in action. Online speculation inevitably followed the release. Some observers misinterpreted the streak's cylindrical shape as evidence of an artificial object. However, Loeb and imaging engineers clarified that such elongation naturally results from the integration process, not from physical structure. The NAVCAM's resolution at that distance, roughly 12,000 km per pixel, cannot resolve any actual detail. Meanwhile, telescopic data continue to reveal what makes 3IAtlas extraordinary. Observations from JWST, Hubble, and ESO's Very Large Telescope show its coma rich in carbon dioxide, carbon monoxide, and trace metals. Unusually, its nickel-to-iron ratio fluctuates sharply as it nears the Sun, behavior unseen in any previous comet. Researchers believe this comes from volatile organometallic compounds such as nickel tetracarbonyl and iron pentacarbonyl sublimating at different temperatures. By comparing spectra from orbiters and Earth-based telescopes with possible visual data from Mars's surface, scientists could link chemical activity to brightness and tail evolution, connecting composition with direct observation for the first time in an interstellar object. Implications and what comes next. The next challenge is verification. Researchers are analyzing the NAVCAM's metadata, including exposure time, pointing angle, and sequence timing, and matching it against the predicted motion of 3IAtlas. If the streak's direction and brightness profile align with models, the case for confirmation will be strong. ESA's orbiters are expected to release their October data set soon. Both Mars Express and TGO tracked the comet before, during, and after its closest approach. If their spectral readings show changes consistent with what Perseverance might have observed, it will help confirm that the rover's image captured the same event. NASA's Mars Reconnaissance Orbiter, MRO, may also play a role. Its high ISE camera, although designed for surface imaging, can occasionally detect bright transients. If it observed the same region of the sky, even a faint detection could corroborate the NavCam result. Meanwhile, observatories on Earth are still following 3IAtlas as it moves toward the Sun. Data from Gemini South and the VLT have already revealed new insights into its chemistry. Nickel compounds vaporize earlier than iron ones, explaining the changing nickel-to-iron ratio as the comet warms. This supports the idea that these metals exist as volatile organometallic molecules rather than being locked inside solid rock. Such findings have implications beyond one comet. They suggest that interstellar objects may carry complex chemistry shaped by alien protoplanetary disks, offering direct evidence of chemical processes that occur around other stars. In that sense, every observation, even a streak, contributes to understanding how matter evolves across galaxies. If the streak is ultimately identified as 3IAtlas, it will be the first interstellar object imaged from another world, expanding the frontiers of planetary observation. If not, the analysis remains valuable. It will refine how long-exposure imaging is calibrated on Mars, helping future missions identify genuine transients while filtering out false positives. The broader takeaway is that robotic explorers like Perseverance are no longer limited to planetary geology, they are becoming part of a multi-world scientific network, observing space from multiple vantage points. That transformation from local exploration to interplanetary observation marks a quiet but profound shift in how we study the cosmos. Whether it's 3IAtlas or not, the image marks a turning point in how we observe space. Mars has joined the search beyond our Sun. Every new frame brings us closer to the unknown. Thanks for watching Dark Core.